Hello everyone, welcome to the Let's Get Solving with Google Cloud series. My name is Srinivas Makam. I'm a customer engineer focusing on application modernization within the Google Cloud team. So this is a second of a four-part series on Kubernetes and Google Kubernetes Engine. In the first part, we talked about how we can migrate an application running in VM into a container and run it in Kubernetes Engine. In the second part, which is this specific part, we're going to talk about how we can secure, Kubernetes clusters as well as applications running inside the Kubernetes clusters, right? Using role-based access control. So that's primarily the focus of this specific talk. In the next two parts of the series, we will talk about how we can do monitoring and logging with Google Kubernetes Engine. And in the last part, we'll talk about how we can deploy a serverless application within Google Kubernetes Engine. So before we get started with the lab, I kind of wanted to set a baseline on Kubernetes and Google Kubernetes Engine security so that it becomes easier kind of when we run through this lab. So Kubernetes provides a whole bunch of security features which makes your container secure. So let's start off first with namespaces, right? So namespaces is a way in which you can kind of split up your clusters into multiple domains, and you can have much more control over what runs in each namespaces. So role-based access control is what we're going to talk more. So I'll cover that later. Network control policy allows you to control which pod can talk to which other pod within your cluster. Pod security policy allows limiting what your applications can do in a particular pod. Secrets allows you to maintain application secrets in a very secure manner. And audit logging allows you to kind of have a trail of what really happened in your clusters, right? So all these are pretty important features. So on top of the Kubernetes engine, Google Kubernetes Engine provides a whole bunch of security features. And I'm not going to walk through every feature that I've described here. But at a high level, it's good for us to know that the security features can be divided into three main areas, right? The first one is on the infrastructure side. So this talks about how you can secure your master nodes and worker nodes within the Kubernetes cluster. The second one is about the software supply chain, and this talks about how you can secure your container images and make sure that only secure images are actually getting deployed. And the last part is about runtime security, and this talks about, say, when you run your containers, how do you make sure that the runtime is secure, right? Say if there is a vulnerability in one container, obviously it should not disturb the other container that is running in the same node, right? So that's kind of what the runtime security talks about. So as I said, right, so the focus of this specific lab is going to be role-based access control. So when we look at role-based access control, right, there is a very good similarity between role-based access control and the IAM. IAM is the identity access management available within the Google Cloud, which allows us to protect resources within the Google Google Cloud, right? With role-based access control, it's a similar equivalent. Here we are protecting resources within your Kubernetes cluster. So the similar concept of who can access what resources using a bunch of permissions, right? So that's kind of what a role-based access control is. And the who can be, let's say, a user, or it could be a service account. And the which one here applies to the Kubernetes resources. And this could be a cluster, a namespace, pod, deployment secrets, any Kubernetes resource, right? So in this specific lab, what we will do is we will create a bunch of namespaces within a cluster and show that how we can restrict these access to the namespaces, based on different service accounts that are applied to different instances, right? So that is one scenario we will cover in this lab. As a second scenario, what we will cover is we will deploy an application within the Kubernetes cluster and show that using Kubernetes service accounts, how we can limit the access to what that particular application can do within the Kubernetes cluster. All right, so let's get the ball rolling. So we'll get started with the lab now. Before we get started with the lab, so this is the link to the QR code for you to get started with the Qwiklabs, and it's important for you to use this specific QR code, because if you finish the lab associated with this QR code, which is actually the first part of this series, then you get access to a 1 month of free Qwiklabs access, and using which you can run through pretty much any lab within the Qwiklab, right? And that is pretty powerful. Okay, so first thing we will do is I already have the lab page that is opened. So this is specifically the lab we're going to talk through using role-based access control in Kubernetes engine. So the first thing we'll do is, we'll start the lab. And when we start this lab, it's going to create a sandbox within the Google Cloud environment with a project and everything set up for us. And so now we see, what is the username and password and the project that is set up for us. And the next step is I'm going to open an incognito window where we can run through this lab. And why an incognito window? It's mainly because, let's say if you have a bunch of accounts that you're already using, you do not want your Qwiklabs to get confused with your pre-existing accounts. You want your newer account to be used, and that's the reason it's always better to use an incognito window. Okay, let me switch to an incognito window now. Okay, so now that I have switched to the incognito window, let me log in. So I will log in using my credentials that was set up in the lab when I started the lab, right? So that's the credentials I'm going to use now. Use the password associated with that. And once we log in, it's going to ask us to accept a bunch of terms and conditions. We will just accept that. That's a standard stuff. And once we log in, we're going to see the very familiar, the Google Cloud console actually, with the project and everything already set up for us. Okay, so we'll do agree to these terms. Okay, and then we will do select the particular project, which is the project that we saw earlier. I'll just make the font a little bigger. Okay, so now we have created, we have already entered the Google Cloud sandbox environment. Let's activate the Cloud Shell. So Cloud Shell is pretty much a VM which has a whole bunch of Google Cloud tools already pre-installed, and like G Cloud and everything. So that makes it easier for us to talk to the GCP console. And if you want, you can install the G Cloud separately in whichever client system that you're working on. That is perfectly fine. All right, so we got the terminal window. What I will do is I'll create two more windows because I'm going to be running a bunch of sessions simultaneously. So, and then let me make this a little bigger. And what I will also do is create my code editor, and this is important because I'm going to this is my IDE within the Google Cloud, which I can use for editing whatever code I'm checking out here. And I want to show a bunch of things before I get started with the lab. So let me make this also a little bigger. Okay, so before I go through exactly what this lab does, I actually want to kickstart certain things so that it becomes faster when I'm going to run through a script which creates the clusters and the instances. So I want to do that first so that it'll be much I can run through that while the script runs, right? I can explain what the lab is doing, so that way I'll save some time. Okay, the project is already set here, right? Okay, so we are good. So this is the specific project. So as I said, right, I'm going to start a bunch of things. So let me do the setup for that. The first thing I need to do is set up my zone and the region. So let me do that. Okay, so I've set it up for US Central Zone and region, and then I'm going to clone the project here. Okay, so this I'm going to show you what is exactly contained. So it's pretty much a Terraform script to do a bunch of things. I'll show you what actually the script is doing. All right, so I go to that specific directory, and what I will do is run the make here, which is going to run through the script to create all the resources, right? So while this is doing, what I will do is first let me switch back to my lab, and I will show you what the lab is doing, and then I will come here, and while the resources are getting created, I'll show you the resources itself, right? So as I was telling you earlier, right, there are two scenarios that we are going to do. The first scenario is this, assigning permissions by user persona. So let's go to that. So I'll show you what this specific lab is doing, right? So let's go to that. So here, if you look here, right, so this is my GKE cluster that's going to get created. And what I'm going to do here is create, first what I'm going to do is create 3 service accounts. And the service accounts are going to be called as admin, owner, and auditor. And I will assign those 3 service accounts to 3 different compute instances. And then within my GKE cluster, I'm going to create 3 namespaces. And I'm going to assign 3 different permissions to those service accounts that I have created, right? The way I'm going to do it is the owner service account will have access to all the namespaces to read and write. And the auditor service account will have permission to read only to the dev namespace, and it cannot even write to the dev namespace, right? And that's kind of the environment that I'm going to create. And I will show that using the role-based access control, this set of permissions like the owner, auditor, and the admin permissions, right? How I set it up and for this specific use case, right? So that's kind of what I will cover in the scenario 1. And in scenario 2, what I will do is I will deploy a sample application called as pod labeler. So pod labeler is an application. What it will do is it will go and label a hash to all the pods running in the cluster, which means that particular application running in the pod needs to have the permission to change the metadata of all the pods, right? So which means it needs to have a specific permission called as a patch or a write permission to the pod. So what we will show and demonstrate is that only when the application that is running in the pod is running with a specific service account, it can go and change the label of any other pod. If it does not have that service account associated with the application, it will not able to make the changes, right? So that's kind of what we will show. Okay, so now that we have seen what this specific lab is going to do, let me go back to my incognito window and see where we are. Okay, so now we see that there's a whole bunch of things that has happened, but the container cluster creation is still running. So while let it run, so let me show you what exactly some of the things that I wanted to show you. So let me go to my Terraform. So let me go to my, so the main.tf file is the one which is basically, running through a whole bunch of things. But what I am more interested in showing to you is the IAM.tf file. So what I wanted to show here is, first thing is we are creating a new IAM role called as Kubernetes API read-only IAM role, right? And which has these permissions. It has get permission. Basically, it can only do a get on the clusters. It cannot basically do any write to the clusters. Basically, it cannot create a cluster, right? And then we have 3 service accounts: an owner service account, an auditor service account, and an admin service account. And what we are going to do is associated the read-only service account to the owner and the auditor. So using these 2 service accounts, I cannot do any cluster creation, right? So this is nothing to do with the Kubernetes RBAC. This we are still talking about the GCP IAM control here. So the 3 service accounts that we have created in the GCP, out of which basically the auditor and the owner service account cannot create clusters because they're associated with this role, and the admin can create clusters and everything because it is associated with the container admin role, right? So that's primarily what this is doing. Okay, so now let's look at what gets created in the instance. So let's look at that, the manifest that gets created in the instance. The first thing I want to show you is the RBAC that gets run within the what is the role-based access control policy that we're going to apply within the Kubernetes cluster, right? So first thing is we're going to create 3 namespaces, dev, prod, and test, that we have shown earlier. And what we're going to do is create a role called dev read-only role, and obviously, as the name says, it can only do a get, list, and watch, right? It cannot do any write operations. And then we're going to do we're going to create another role called cluster role, and this role can do all read write, right? Pretty much any operation within the cluster it can do. And then we're going to, now we have created 2 roles. If you look at it, one, there is a namespace based role, and it can it's only can do access on the dev namespace. And then we have a cluster role, which is pretty much everything in the cluster, right? And now we're going to do a binding. So we created the role, we have to bind it to something. So what we're going to do is we have created the cluster role binding we are doing with the cluster role, and I have bounded to the owner service account. So that is what I have done, right? So I have bound this to the cluster role to the owner service account. And then what I have done is the other role binding that I have done, the namespace role binding, I have bounded to the auditor service account. So which means my auditor service account can only do a read of my dev namespace, but my owner service account can do a read and write across all namespaces, right? So that's primarily what we wanted to achieve. So this is going to be what scenario 1 is going to do, right? Now, for scenario 2, what we have an application running. As I mentioned, it's a pod labeler application. So if you look at it, the application is a simple deployment. And what is more interesting is, so we have created a role called as a pod labeler role, and we have created a service account, right? Which is bound to the above role. So it's bound to the the previous role that we have created. In the first example we are going to run, when we run this, we see that the deployment is not bound to any service account. This line is commented out. So which means it will use the default service account, which does not have permission to label the pods. So this actually will fail. So then we'll apply fix 1 of the same version of this application. And if you look at it, in the fix 1, we have created a service account associated with the deployment. So let me go. Yeah, here, this is the service account. And we have associated this service account with the particular application or the deployment. This will still fail. The reason being, I still have only list role associated with this pod labeler, right? I don't have a permission to edit the labels for any pod, right? Then what we will do is apply the fix 2. In the fix 2, what we will do is we will have the capability to do also the patch. We have changed this role, and that would be what is the final service account that we are going to apply. And that's kind of what we will show in the scenario 2. Okay, so now let's go back and see what is happening to our script. Okay, our script is done. Now all the resources are completed. So let me go back to my Google console window, and let me show you what are the resources that has got created before we start operating on the resources, right? Okay, the first thing we wanted to check is what are the instances that got created. Let's look at that. So here we see basically 5 instances, right? The 2 instances are associated with the Kubernetes cluster, and then there are 3 instances which are the instances on which the service account is applied. So let me show you 2 more things. So first I will look at the Kubernetes cluster. I'll just show you the cluster got created, and then I will show you the IAM and the service account that we have created. Okay, so this is the cluster with 2 node cluster that we have seen. Then what we will show is we will show you the service account, right? So let me look at the service account. All right, so here if we look at the service account, there are 3 service accounts, right? One is the admin service account, auditor service account, and the owner service account. So those are the 3 service accounts that we are primarily interested in. And if I look at the IAM roles, I will see that for each of these 3 accounts, we will have specific roles that are applied, right? So whatever roles that I have created, and I have bound to those 3 service accounts. Okay, so now we are good to go at this point. So we will go here. First, what we will do is we'll log into the admin cluster. So that is where we are going to create the namespaces. So let's log into the admin cluster, and we will apply the namespace creation. Okay, so we are logged in. So I will update this. So what this is going to create is going to create these three namespaces and the roles associated for these three namespaces, which I showed in the Terraform script, right? So now we have created these three things. What we will do next is that we will go to the owner node, because this we have done it from the admin instance. Now we will go to the owner node. Right, first I think I need to set the zone. Okay, so now I have logged into the owner node, and inside the owner node I will enter the application creation, which is the hello server application, which is a, the basic default application. So I've created the application, and then what I will do is so what I've done here is I've created inside the namespace dev, I created the application, and I will also do it for the prod and the test namespace, because we have three namespaces, right? So I'm doing in the prod namespace, and then I will do it in my test namespace. So I've deployed the same application across all the three namespaces. All right, so now let's look at what is actually running. So as we can see that in all the three namespaces, I have the same application running, right? So now let's look at a few more things. Let's also log in to the auditor instance. So inside the auditor instance, we have basically it's going to run as the service account, which can only do a read to the dev namespace, right? So that's kind of what we wanted to show. So let's do that. All right, so we have logged into the auditor namespace. First, let's try to get the pods of all the namespaces, right? And we see that we are getting an error, obviously because the auditor instance does not have the permission to read all the namespaces, right? So we see an error. And then what we will do is we will try to access the pods from the dev namespace. Let's see what happens. So here we are able to see from the dev namespace, right? So that's because I have access to the dev namespace, I'm able to see it. But if I list the pods in the other namespaces, I'm failing because I don't have permission. And let's also do to access from the test namespace. Well, am I going to be able to access from the test namespace? And that's also failing because I don't have permission for that actually. And the last thing I will do is I'll try to run a deployment to create something on my dev namespace, right? And that is also failing for me. The reason being I have only read permission on my dev namespace. I don't have write permission on the dev namespace. So that is pretty much what I wanted to show from the scenario 1. So now let's go to scenario 2. So for scenario 2, let me go to the admin instance and let me deploy the sample application, which is the pod labeler application that I mentioned, right? So let me deploy that pod labeler application. Okay, so I've deployed it now. And after deploying, let's look at what is the status of that particular application. So what we will see, we should see ideally, is that this application is going to be crashing. Right, let's look at it again. Okay, so there is a crash loop back off. The application is crashing and it's reporting an error. So let's look at why it is failing, right? So let's look at that. Yeah, it says back off, restarting failed container. So we can also look at the logs associated with it. And it's going to say there is a forbidden. This is forbidden because I'm not able to actually do what I want to do because I do not have the actual permission, right? So what we will do is that let's look at what service account is actually being used, right? For this particular um, application that is running, what service account is used. So let me just grep on this account. Okay, so here if you see, it's using a service account default. As I showed you earlier in the pod labeler, right? The application, first the pod labeler application, it is in my application, I don't have any service account. So it is using the service account default, which does not actually have any permission to, make the changes, right? So now what we will do is that we will go here and we will apply the fix one. The fix one, let's apply that. Okay, and the fix one is still not going to fix anything for us. The reason is at this point, so we will run it as a pod labeler service account. Previously we were running as default, now we are running as a pod labeler service account. But as I was telling you earlier, in the fix one, if you look here, right, we still do not have the permission to patch or make changes to the other pods, right? So what actually we need to do now is we need to apply the fix 2. So let's go back and apply the fix 2. And by the way, right, these logs, if you want, you can look in the in the GCP logging console also. So that will be easier. The API server logs as well as the the container logs, you can look at it in the same place. So now I'm applying the fix 2. Now in the fix 2, as we looked at earlier, right, it actually has the service account, which is pod labeler, as well as if you look at the role, it has the patch permission, right? And typically what is better to do at this point is that we should delete it and so that we can the deployment can restart it. So let me just delete it and after that let's let it restart it. And once it is done, let's see, okay, so now we can see the pods are running. So the earlier the pod that was failing, it was erroring out, right? Now we can see it is running. And the other thing I also wanted to show is look at the logs of that particular pod. And if you see here, it is labeling the pods, and it is doing what it is supposed to do, right? So that's kind of what we have done here. And if we look at yeah, so this is the the pod labeler that is running, and it has already labeled the pods. So what we have shown here is that the scenario 2 here, right, we try to deploy an application and shown that unless the application has the right permission to make any changes to other pods, with which we can do it with the service account, it is not able to run. So that's what we have shown at this point. Okay, so we are kind of more or less done with the lab. So now what I will do is I will switch back to my slides and I will kind of try to summarize what we have done and what are the next steps, right? So I will show that in the going back to the slides. All right, so let me kind of summarize what we did in this specific lab, right? We first started off with scenario 1, and for that what we did was we created a Kubernetes cluster, we created 3 namespaces, we created 3 service accounts, associated those 3 service accounts to 3 different instances, and shown that an admin can do all operations, owner can read and write to namespaces, and auditor service account can only read to dev namespace, and it cannot do anything to the other namespaces, not even list, right? And in scenario 2, what we did was we created a sample application, deployed the application with the default service account, and we showed that the default service account cannot make any changes to other pods. And then what we did is we associated a service account which has the capability to make changes to the pods, and shown that that is able to make changes to the other pods. So once you run through these labs, this specific lab, right, this is basically a quest that you can complete if you are interested in more from a security perspective. So basically, this is a set of labs which are focused primarily on Kubernetes engine security. There is around 5 to 6 labs with different levels of difficulty, which covers all the Kubernetes concepts. It will be very good if you can kind of walk through these labs. Okay, let me go back to my slides now. And so this specifically is the QR code that, as I projected in the very beginning, right? Please use this QR code for you to get 1 month of free access. Let me go back to my series topics. So just summarizing, right? So what we covered today was, how do we secure access to Kubernetes clusters, as well as, how do we secure the applications running inside the Kubernetes cluster. And in the next 2 parts of the series, we will cover, monitoring and logging, and also how do we deploy serverless applications in Google Kubernetes Engine. Thanks for watching. Hope you had fun. Looking forward to seeing you again. Thank you. Bye.